All right, so continuing with simplifying rational expressions. Today and tomorrow, I'm just going to stick with multiplying rational expressions. So a couple themes, it's still section 9.4 here, but one of the main themes that we're keep going here is that we still need to figure out the restrictions, okay? And again, your restrictions are when the original denominator equals 0. So in this case, your original denominators are x plus 3. So x cannot equal negative 3. X minus 5 equals 0, so that means x cannot equal 5. And x minus 4 equals 0, so x cannot equal positive 4. So three restrictions here: x cannot equal negative 3, x cannot equal 5, and x cannot equal 4. And really here, it's even more important that we're doing these restrictions first. So again, we're multiplying these two rational expressions together, and you got to figure out those restrictions right away. Okay, don't put that off, because once you start to get into simplifying everything, it's you kind of forget about what you had there. So anyway, you're just looking for common terms in either numerators and denominators. This is one big fraction. I could go and rewrite this thing as x plus 2 times x minus 4 times x plus 3, like we did yesterday. You just go multiplying, you just go right across the numerator, right across the denominator. We got x plus 3, x minus 5, and x minus 4. Okay, so we're just looking for same binomials in the numerator and denominator. So I get an x plus 3 divided by x plus 3. X minus 4 divided by x minus 4. We're left with x plus 2 divided by x minus 5. And that's it. Don't forget about your restrictions. We got negative 3, 4, and 5. All right, that's it. So some of these you're going to have to do, some more factoring to start. I kind of wanted to start off with something easy here, just showing you, hey, original denominators. You got to use those when you're figuring out your restrictions. And then you're just looking for the same term in the numerator and denominator. Okay, it doesn't matter, which fraction it's in, as long as, like in the case of x plus 3, this one's in the numerator, this one's in the denominator. They reduce down to 1. It doesn't matter which fraction they're in. Okay. So next up here then, down here, we do have a little bit of factoring to go, but first up, let's get those restrictions. So I got to do 5x plus 5 equals 0, and x equals 0. That's all I got in the denominators there. So this will be 5x equals negative 5, x cannot equal negative 1. Down here, just x equals 0. X cannot equal 0, sorry. All right, so again, original denominators, that's what we said equal to 0. Those original denominators cannot equal 0. That is like the biggest thing you can take away from this stuff, all right? So next up, a little bit of factoring to do here. You cannot just simplify the 5x and the 5x, okay? Because this is 5x plus 5. In the case of, like let's say x was equal to 1. If I put 1 here, I'm going to get 5. If I put 1 here, I'm going to get 10. It'd be 5/10, which is 1/2, okay? We can't just reduce this down to 1 here. So anyway, in the denominator, I can factor out a 5, and I get 5 times x plus 1. Same kind of deal up here. 10x plus 10, I can factor out a 10. Everything's divided by x. All right. So if you want to kind of condense everything here in the numerator, I do have 5 times 10 is 50. X times x plus 1. Just trying to put everything in order here for you. Down here, I'm going to move the x over with the 5. 5x times x plus 1. You can start to reduce up here, like take an x plus 1 for an x plus 1. 10 divided by 5. I just found with simplifying the coefficients, it gets a little bit easier doing this. So anyway, I got 50 divided by 5 is 10. Okay. X divided by x is 1. X plus 1 divided by x plus 1 is also 1. So all I'm left with is 10 over 1, which is just 10. Don't forget about your restrictions. Oh, x cannot equal negative 1, and x cannot equal 0. Okay. So again, important things here. Right away, take your original denominators, set them equal to 0 so you know your restrictions. Next up, do your factoring. This is an optional step right here. I just like to do this because I think it helps people as far as, like I said, reducing coefficients. You know, I multiply everything out. It doesn't matter the order I have this stuff. You know, it's just kind of my tendency to go, you know, your coefficient, then x, then any binomials I might have, okay? So pretty good problem here. You know, as always, when you're doing these, like, watch a video once and go back and try and do it on your own, okay? All right, so next up here, kind of similar deal. Let's take care of our restrictions over on the side here. So I got to do 3y plus 15 equals 0. So that means 3y equals negative 15. Y cannot equal negative 5. So that's my first one. Second, I got to do 10y plus 40 equals 0. So that means I got 10y equals negative 40. Y cannot equal negative 4. All right. So those are your restrictions. We know those right away. You know, like you saw in the last problem, you know, everything reduced down at 10. So you really don't want to wait till then to try to figure out your restrictions. You're going to think all's good in life and, you know, totally forget about those restrictions. So let's start to factor this. We got 5 times y minus 4. Again, just a GCF. All right. We got 3 times y plus 5. Up here I got 7 times. I can factor out 7 there. I get y plus 5. Down here I factor out a 10. I get y plus 4. Okay. Now, like I said, you don't have to do this next step, but I think it does help to try and condense everything. I'm going to multiply my coefficients up in the numerator. 5 times 7 is 35. I got a y minus 4, and I also have a y plus 5. Down here, I got 3 times 10 is 30. I have a y plus 5, and I also have a y plus 4. All right, so simplify this. 35 over 30, both are divisible by 5, so we can go 7/6. I have y plus 5 divided by y plus 5 is 1. It's y minus 4 and y plus 4. Can't do anything about it, so they're just coming along for the ride there. If you'd want to write it as like 7y minus 28 divided by 6y plus 24, knock yourself out, that's fine. And of course, x cannot equal negative 5, and x cannot equal negative 4, okay? So this or this is acceptable, really doesn't matter. You know, it's not like it's going to really change a whole lot, but that's what I need to see. I do think this step helps, you know, like I said, as far as simplifying, especially with the coefficients here, all right? So, last up here, we have x squared plus 9x plus 20 divided by x plus 6, x squared plus 7x plus 6 divided by x squared plus 7x plus 12. This is like a lot of what we're going to see moving forward here. So again, let's take care of those restrictions first. So I have x plus 6 equals 0, so x cannot equal negative 6. That one's easy. Next up, you have this x squared plus 7x plus 12 equals 0. So that's going to have to go x plus 3, x plus 4 equals 0. So x plus 3 equals 0, so x cannot equal negative 3. And with the x plus 4 equals 0, x cannot equal negative 4. So I have 3 restrictions on my denominator. So now we're going to do a lot of factoring. X squared plus 9x plus 20. We're going to factor that into x plus 4 and x plus 5. This denominator is already done, so we don't have to do anything with that. Over here, factors of 6 that add up to 7, x plus 1, x plus 6. And down here, where is it? X plus 3 and x plus 4. So I'm not going to write that middle step like I did up here. Again, you're just looking for same binomial in the numerator as in the denominator. And you can only go 1 for 1. All right. So I got this x plus 4 and this x plus 4. So 1 for 1 with x plus 4s, they're gone. X plus 6 divided by x plus 6 is 1. And that's it. We're left with x plus 5 and x plus 1. Divided by x plus 3. If you'd want to rewrite this as x squared plus 6x plus 5 divided by x plus 3, that's fine. And again, don't forget your restrictions. X cannot equal -6, -4, and -3. Okay? So, main ideas. We haven't really changed a whole lot. First up, take care of your restrictions. Set the original denominators equal to 0. That's important. Next up, do some factoring. Okay, factor completely. It could be a GCF like these, could be factoring in 2 binomials like these. But main idea here is factor completely. Then look for either identical binomials or identical monomials in both the numerator and denominator. And you can only go 1 for 1. We'll talk about that more tomorrow. But you gotta look for the same binomials in the numerator and denominator. All right. As always, let me know if you have any questions. Have a good day.